Alright, if you're watching this video, it should be an e-learning day on February 10th, and you should be an Algebra I student. If it's neither one of those things, if neither one of those things apply, I should say. In other words, if you're in 8th grade math versus Algebra I, you're watching the wrong video, and if it's not an e-learning day on February 10th, you don't need to watch it at all. I guess I just forgot to delete it or something. But we're going to start Chapter 7. In Chapter 7 is essentially called Exponents and Polynomials. So that word polynomial, don't let that scare you. We're not really going to talk about that today. It's an 8-section chapter, and we'll have a test over 7.1 through 7.4, and then we'll have a second test over 7.5 through 7.8. 7.1 through 7.4 covers the exponents part, and then 7.5 through 7.8 covers the polynomial part. So that's kind of a scary word, but I promise they're not that difficult. It's just like a lot of things in math, they got weird, scary, fancy names. But so you've done exponents before. This unit, this chapter, this whatever you want to call it, is going to be exponents like you've seen before, but the volume is going to be turned way up. So some of it will look like review, some of it will be new, and then by the time you get to 7.4, it'll look like something you probably didn't even know existed before. Not real hard, It's just one of those things that takes practice. So homework problems, they won't take very long, but in order to get good at it, you'll have to do more than like 10 a night. So the amount you do will go up a little bit, but the amount of time you spend on it won't be much different than a regular homework. So anyway, I'm going to be quiet and get started here. Section 7.1 is called integer exponents. And again, integers are, well, I sure hope you know this, but they're those numbers that have no real starting point and no real ending point, but follow this pattern. In other words, it's all the negatives, all the positives, and then zero, kind of the divider between negative and positive. But we skip all the fractions, we skip all the decimals, we skip all the irrational numbers, just regular old numbers that you're used to. So we should know what to do with these kind of exponents. Positive exponents mean repeated multiplication. In other words, 3 squared means 3 times 3. 4 to the 5th means 4 times 4 times 4 times 4 times 4. All right. I think earlier in this year, around chapter 2, we did talk about what exponents of 0 look like and what negative exponents look like. But in case you've forgotten, or in case we didn't do it in chapter 2, let me remind you. If you take any base to the 0 power, it's equal to 1. Every single time. So 3 to the 0 is equal to 1. X to the 0 is equal to 1. The quantity of x plus y to the 0 is equal to 1. Negative h to the 0 is equal to 1. The only exception is if you have something like negative of 2 to the 0. That's equal to negative 1 because the negative is not part of the base. We're taking 2 to the 0, which is 1, and then bringing the negative over. That's the difference between here and here. The negative is part of the base, and any base to the 0 is 1. Here the negative is not part of the base, so the negative would carry over. It's no different than doing a problem like 8 minus 4 to the 0. Well, you would say that's 8 minus 1, which is 7. We essentially did the same thing right here. That negative just dropped down, and the 4 to the 0 became 1. Same idea. So, exponent of 0, really easy. Everything is 1. You just have to know whether the negative is or is not part of the base. That's honestly as difficult as it can get. Negative exponents, on the other hand, are a little bit weird. Instead of representing repeated multiplication, like positive integer exponents do, negative integer exponents represent repeated division. But instead of saying like divide by 3, divide by 3, divide by 3, we write them as fractions. So in other words, a to the negative n equals 1 over the exact same base, but to the positive exponent. Okay? So if we had 3 to the negative second, that means divide by 3 twice. Dividing by 3 twice is the same as multiplying by 1/3 twice. Okay, just like dividing by 2 is the same as multiplying by a half. So instead of putting divide by 3, divide by 3, we just say that's 1 over 3, but to the positive exponent. So we're going to divide by 3 twice. Hopefully you remember all that. If you have something like negative 7 to the negative third, that would be 1 over the exact same base, including all those parentheses, to the positive third. Now if the negative's on the outside, like negative 8 to the negative fourth, again, ignore this negative because it's not part of the base. That would be 1 over 8 to the fourth, and then bring that negative over at the end, and now it's just a negative number. This is a negative number, this is a negative number. It's not a negative base. That's the only difference. So you literally put 1 on top, write the exact same base on bottom, and the negative exponent becomes a positive exponent. So the type of problems we'll do in this section, there's a little bit I'm skipping in this section just because I think you've done it to death early in your math career, and I just don't think it needs rehashed. So, but if we have something like 5 to the x to the 0, and you simply had directions that said simplify, or just simplify. So in other words, we can write that more simple. Well, this means 5 times x to the 0, which would be 5 times 1, which would just be 5. Now you don't have to show all this. I'm just overworking just so you can see the thought process here. All right, if you had 9r to the 0, y to the second, well, that would be 9 times 1 times y squared, which would just be 9y squared. So that's simplified, considered simplified. If we had h to the 8th, j to the negative 4th. We're going to learn that there's a much quicker way to do this, but before I just show you the quicker way without any explanation, I don't think that would be very helpful. So we could rewrite this as h to the 8th times, now use that negative exponent rule, 1 over the exact same base to the positive exponent. And now I'm getting ready to multiply fractions, so I'll put this one over 1, multiply straight across, and I get h to the 8th over j to the 4th. Okay. So in order for something to be considered simplified, there should be no negative exponents in the final answer. So since that has a negative exponent, we want to work this problem until there aren't any negative exponents. Okay. So if I had r to the negative third, t to the 9th, well, this would be 1 over r to the third. That's using my negative exponent rule. Now, that's a positive exponent, so that's just going to stay t to the 9th. But I'm going to put it over 1 just so I can multiply straight across. And I'll get t to the 9th r cubed over r cubed. So that's considered simplified. Let's do a to the negative fourth, b to the negative seventh. Well, that's going to be 1 over a to the fourth times 1 over b to the seventh. Multiply straight across. 1 times 1 is 1. A to the fourth times b to the seventh gives us a to the fourth, b to the seventh. Let's do c to the negative fifth, d to the third, e to the negative first. So this one would be 1 over c to the fifth times d to the third. I'm going to go ahead and just put that over 1. But I didn't move this to the denominator because it was a positive exponent. So it's not going to move down. It's going to stay where it is. And this would be, not equals, times 1 over e to the first. Now technically, if I don't write that to the first, it's better or considered more simplified. In other words, it's like a ninja one. You don't have to write anything to the first power. But I just wanted to write it there so you would see I used the rule. And now we're going to multiply straight across. So 1 times d cubed times 1 is going to be d cubed. C to the fifth times 1 times e is going to be c to the fifth e. So that's enough of doing them the long way. Make sure the camera's doing okay. That's enough of doing them the long way. I'm going to show you the shortcut. The shortcut is simply this. If you think about this being over 1, anything that is positive stays where it is, and anything that's negative just gets moved down and becomes positive. In other words, I could skip all this and jump straight to here. H to the eighth is positive, it'll stay where it is. J to the fourth is negative, just send it downstairs and it becomes positive. Think about this being over 1. Negative third is negative, so send it downstairs and it becomes r to the positive third. T to the ninth is positive and it's in the numerator. It's upstairs, so it stays upstairs. Okay? Think about these being over 1. Both of them are negative, so you can just send both of them down. Now when you do that, you have to put a 1 up top. You can't just leave it blank. All right? So a to the negative fourth becomes a to the fourth in the denominator, and b to the negative seventh would just come down and become b to the seventh in the denominator. Same thing on this one. The c and the e are what's negative. Send both of them down. Negative 5 becomes positive 5. Negative 1 becomes positive 1. And then d cubed, it was positive, so leave it alone and leave it upstairs. Okay, so let's try that. Let's do g to the seventh, h to the negative fourth, j to the negative eighth. So think about that being over 1. G to the seventh is positive. Leave it alone. It'll stay up there. H to the negative fourth. That's negative, so send it down and it becomes positive h to the fourth. J to the negative eighth. It's negative, so send it down. It becomes j to the positive eighth. And you get a skip doing all this, applying the rule and multiplying across. Okay? But if I would have said this from the beginning and not shown you where it came from, you would have been really confused as to why you were doing what you were doing. But now that we hopefully understand, we can just do a shortcut. All right. The same applies for numbers. I guess I should say that. So if you had like 2 to the negative third, a to the fourth, b to the sixth, c to the negative third. Well, 2 to the negative third has a negative exponent, so send it downstairs. A to the fourth is positive, so leave it up, because remember, it's technically up right now. B to the sixth is positive, so leave it up. And then c to the negative third, that's negative, send it down, we get c to the third. The thing, you do want to multiply these out, okay? So we would get a to the fourth, b to the sixth over 8, c to the third, because 2 cubed is 8. The last thing to cover is what happens if you're given one and you have some exponents in the denominator. In other words, if I have a to the fifth, b to the negative sixth, and c to the seventh. Well, the same thing is going to apply. A to the fifth is positive, leave it alone. B to the negative sixth, that's negative, so send it down. That becomes b to the positive sixth. And c to the seventh is positive, so leave it where it is. Don't move it up or anything like that. Leave it where it is, and it becomes c to the seventh. That a to the fifth off center is bothering me. So we would end up with that for an answer. Hopefully your next question would be, well, what do we do if there's a negative here? Do we send it up? So let me do one the long way, and we'll discover what we should do and see if we should send it up or not. So let's just do a to the eighth over b to the negative third. What I'm saying is, should our answer be, well, a to the eighth, leave it alone, and b to the negative third, it's negative. I'm used to sending something that's negative down, but it's already down. So should I send it up? So should we get this, which would just simplify to this? Right? That's what I want to know. Is that right? So let's kind of do it the long way and see what we should do. So to do it the long way, we'll apply that negative exponent rule. So I'd get 1 over b to the third. So now I have a fraction in a fraction. In other words, I'm dividing by a fraction. Well, when you divide by a fraction, you multiply by the reciprocal. I think you guys are fond of saying keep, change, flip, or something like that. But we would have a to the eighth over 1 times the reciprocal of 1 over b cubed is b cubed over 1. And we do get a to the eighth b cubed. We did get the answer that I predicted would happen. So in other words, not only can you take a negative exponent and send it down to become positive, you can take a negative exponent and send it up to become positive. So it's like this fraction bar magically changes the sign. So if we had something like r to the third, s to the negative fourth, t to the negative 10th, u to the second. If it's positive, leave it alone. If it's negative, move it. R to the third is positive, so leave it where it is. S to the negative fourth, it's negative, you're going to send it down. So you get s to the positive fourth. It was negative upstairs, it'll become positive downstairs. T to the negative 10th, negative down, so it'll be positive up. U squared, positive down, so leave it down. All right, let me take a quick glimpse at your homework and make sure that I'm not neglecting something that I should. Okay, let's do one more and then I'll put a stop to the video and put you out of your misery here. If we had 3/4 m to the negative second n to the 4th. Well, again, just kind of think about this being over 1, this being over 1. Okay, really, if you rewrite that, it would end up looking like this, kind of as one big fraction. So just apply your rules. 3 is positive, so leave it where it is. The exponent's positive, not the number, but the exponent. 4 is also a ninja positive 1, so it'll stay where it is. M to the negative second, send it down. It'll become m to the positive second. N is positive upstairs, so leave it alone and leave it upstairs. Homework is going to be section 7-1, and I'll have you do 16 through 23 and 43 through 57. Okay, if this is an e-learning day and you need my help, send me an email, and I don't care to fire up the Google Meet link and we can have a chat over that. Hopefully all is going well. Hopefully it's not too bad outside and you're safe. If you need my help, send me an email. See you guys.